Bonjour, once again, thank you for joining me for this geography lesson. So what we're going to do today is we're going to look at some of the topics that you're going to be able to find in your final question paper. And once again, just want to thank Liberty for this opportunity. But before we go back, but we're just not going to recap on last week. So we're going to focus on revision. Hopefully, we're all back at school next week. So we can start with our last section. We look at rural and urban settlements that we have discussed over the last couple of weeks and finish the syllabus as quickly as possible. But we need to be thorough. So getting straight into it, once again, thank you for all the questions, many questions coming in. And we jump in with climatology today. And Agatha Madaka sent a beautiful question regarding line thunderstorms. Now, line thunderstorms is local climate. And thank you for this question. A very popular question during the exams. But let's get straight into it. So the question basically asks, if we go to our pad, if we go into figure 2.3, and we're going to go to the figure now, we look at line thunderstorms. Now, if you look at the image, before you go and look at the questions, I want to explain line thunderstorms to you. And I'm going to give you a couple of tips that you need to pay attention when you see this type of figure, this type of diagram. Okay, first of all, I'm going to give you a hint. Let's have a look at the date. Okay, this is the 25th of January, 2017. Why is the date important to us? Okay, simple reason for it, because we need to determine the season. Okay, so we can determine when do we experience line thunderstorms. Now, I want to move down a little bit, and like the name indicates, line thunderstorms. So obviously it forms in a line, okay? And if you live in the interior, you will know that when do we experience most of the time thunderstorms? Usually during summer. Now the date on there is a specification that it's summer, okay? That's our first tip. So immediately, what can we can recalculate by saying that line thunderstorms we only experience during summer. But if we look going back to our image, first of all, I'm going to just fill in a little bit of detail over here. So what they've shown us is a front. I'm going to use different color pens. Okay. There's the front. Now let's just quickly define a front. What is a front? The definition for a front is it divides two masses of air. Okay. So that's the definition of a front. It divides two masses of air. In this case, the masses are different. So it means on the one side, we have a different type of air mass than on the other side, or on the other side of the front. So we just define the front. It separates two masses of air. Now, very importantly, so I always tell my students, it's so important, especially when you do geography, you need to remember the basics that you've learned in grade 10. And we looked at the factors influencing South Africa's climate. Which was the factors that influence South Africa's climate? Okay, remember, climate happens over a period of 20 years. So these factors, right, it doesn't happen overnight. It's there, it's always there. It's always going to influence our climate. And you've learned about it. One of the major factors that influence South Africa's climate is ocean currents. Okay, so if you go back to our diagram, what do we know? South Africa sits in a very unique position because on our east coast, the east coast are being washed by what? The warm Mozambican current. Yeah. Just want to show you. I mean, if you go down to Durban, obviously jump into the ocean, the water is nice and warm. Okay. When we go to the west coast, different story. I can guarantee you, most of us Gauteng people won't even dare swimming there. It's too bloody cold. Why? Because of the cold ocean current coming from the Arctic, from the South Pole, and it's known as the cold Benguela current. Okay. Now, if we can quickly look at these two, I'm going to use a different color pen. If we look at these two, the warm Mozambican current, what does it do? It creates warm and moist conditions. Now, if you look at the cold conditions, the cold Benguela currents on the west coast, it creates dry and cool conditions. Okay. So because of this currents, if you look at this diagram over here, it creates different weather conditions for the east coast and the west coast. Now, immediately, if you look at these arrows, they represent, for instance, the cold Benguela represents the cool, dry condition. Why is it cool and dry? Because it's a very cold current. Yeah, not a lot of moisture in it because it's cold. So it creates cool and dry conditions. If you look at the west coast of South Africa, if you look at Namibia, basically desert. In fact, if you look at most of your countries on the west coast of continents, they experience desert-like climates. For instance, if you look at the Sahara Desert, if you go to America, for example, Nevada Desert on the west coast of North America. If you go to South America, you've got Chile, Andes, desert-like. So where there's a cold ocean current, you experience desert-like conditions, arid conditions most of the time. But coming back to our line thunderstorm. So these arrows represents the cool and dry conditions from the Benguela current. The arrows on the eastern side of southern Africa represents warm, moist conditions. Okay. Now, very importantly, as you can see the cloud cover on the one side of the front. Now, first of all, we only experience these type of cloud covers in summer. Why do we experience cloud cover in summer? Because what type of pressure dominates over the interior in South Africa? A low pressure system. Okay. What is a low pressure system? I remember that a low pressure rising air and importantly in a clockwise direction in the southern hemisphere. Okay. So we experience a low pressure system over the interior of South Africa because we experience summer. Okay, so the air rises. Now, in order for rain to form, obviously, what do we need? We need a low pressure system. Air rises, it cools, condenses, clouds, and rain. Now, the reason, if you look at the Western Cape, Southwestern Cape, this province over here, they don't experience summer rainfall. Even though it's hot, low pressure systems exist. They don't experience summer rainfall because even though it's very hot, right? Cape Town experiences beautiful weather over winter, over December. And the air rises. But the fact is there's no moisture content in the air because the air comes from a cool ocean current. There's not a lot of moisture in it. So even though there's a low pressure system, the air rises, there's condensation, there's no condensation taking place because there's no moisture in the air. But completely opposite story on the East Coast. Now, that's the reason we experience our summer rainfall up in the interior in Gauteng and Northwest and Free State. It's because this warm air, moist air, reaches the escarpment, it rises, it cools, condenses, and clouds. Now, basically what happens, this front, coming back to our line thunderstorm, explaining that to you. So, a low pressure develops over the interior. And basically actually multiple low pressure systems develop over the interior. Okay. So it's an extended area of low pressure. An extended area of low pressure is known as a trough. Okay. Now, a trough is an extended area of low pressure. Now, if you draw a straight line, you have your moisture front that creates the moisture front. This is known as a moisture front because what is this? If you come back to what I've mentioned over here, what is a front? It divides two masses of air. In this case, we can identify this front, I'm going to add it over here, as a moisture front. Because what does it actually do? It separates two different areas of moisture. Is there a lot of moisture from the air coming in from the west? No, because it's cool and dry. Is there a lot of moisture coming in from the east? Yes, because it's warm and moist. Now, basically what happens over here, this front is also known as a moisture front. So it separates the cool, dry air from the warm, moist air. Now, in this case, how does this moisture front line thunderstorm move? So I'm just going to draw it in here, just use a different color. It usually moves from west to east because it's driven by the cool, dry air. Now remember, when we look at cool, dry air and warm air, moist air, which one is heavier? Which one is denser? Think of water quickly. Let's assume jump into the swimming pool. Where are you going to find the coldest water? Usually on the bottom of the pool. Okay, the warm water on top. Okay, because what does the cold water do? It forces the warm air, not air, water, above. Okay, same with air. We can also go back to the same scenario when we look at mid-latitude cyclones with cold fronts. What do? The cold front moves in. What does it do with the warm air? It forces the warm air to rise, cools, condense, and clouds. So this is exactly what happens over here. This cool, dry air, right? It's getting separated by the moisture front. So as it moves, I'm quickly going to draw you a cross-sectional profile of this moisture front. Okay, so let's assume this is our moisture front. Okay, so from the one side, I just need to use the correct pens, is the cool, dry air coming in. Okay, from the other side, because of the warm Mozambican current, sorry, just want to use a red pen instead to represent, we have the warm, moist air coming in. Now remember, this is a low pressure system, it's rising air. Okay, here in the middle. Why is it rising? Because we experience summer. Okay, now as the air rises, now remember the cool, dry air is heavier, it's more dense, the warm, moist air is lighter. So what are we going to experience on the side of the warm, moist air? We're going to experience lots of cloud formation because the air is going to cool, condense, cloud, and eventually rain. So this is basically what happens over here. Now keep in mind, as we know it, this system are being fueled with line thunderstorms because also what do we have? I should have mentioned this earlier, but if we just quickly have a look over here, what do we have over the Atlantic? We have the South Atlantic high pressure system. And over the Indian Ocean, what do we have? The South Indian high pressure system. Okay, so what do we know about these two? They move in a anti-clockwise circulation. Why in an anti-clockwise circulation? Because it's a high pressure system and we are situated in the southern hemisphere. Okay, so how does air move? Let's just quickly clean this up a little bit. Okay, and then I'll just quickly redraw it. Okay, let's just quickly draw. Let me just wipe everything off. So remember, air moves from a high pressure to a low pressure. And like I've mentioned, the low pressure exists over the interior because it's summer. Okay, but most importantly, just quickly going to have a look. We have the South Atlantic high pressure system, and we have the South Indian high pressure system. Okay, it's anti-clockwise circulation because we are in the southern hemisphere. We did discuss the two ocean currents. We have the warm Mozambique and we have the cold Benguela. Okay, we have a low pressure over the interior because we experience warm conditions. It's summer. We looked at the date. The air moves from the high pressure to the low pressure. We know this is dry, cool, and this is warm and moist. Okay, now as you can see, all the cloud formation takes place on the east coast of this moisture front because we have warm, moist air. The air rises, it cools, condenses, and we experience cloud. Okay, so that's line thunderstorms. That's basically the foundation of line thunderstorms. Now, if you can remember this diagram accordingly, you will find the questions much simpler. Now, if we look at the questions, 2.3.1, name the front over the interior of the country where line thunderstorms originate. So, like I've mentioned that before, we actually written it down there. The front is known as a moisture front. Why the moisture front? Because it separates dry, cool air from warm, moist air. Okay. So we've answered that question. If we look at question 2.3.2, what evidence suggests that line thunderstorms are illustrated, shown? Okay, I just want to clean my diagram a little bit. Now, what's the evidence? As you can see, I'm going to use my pen. The evidence is quite significantly over here. You can see cloud formation taking place all in a line. Now, these cloud formation obviously is because of convection. It's uprise of air. It cools, condenses clouds, and the possibility of rain. As you can see, we have quite a thick layer of clouds formation in a line that implies lots of rainfall. Okay, cumulonimbus cloud. Okay, if we look at question 2.3.3, why are line thunderstorms generally associated with summer? Now, immediately, why summer? We looked at the date. We identified the date. I'll clean up over here. As you can see, the 25th of January, 2017. Why summer? Because we need rising air for thunderstorms. Okay. Unfortunately, what happens in winter? We have the Kalahari high pressure system over us. It's subsidence. It's sinking air, cooler conditions. I mean, if you look at Joburg today, absolutely no clouds whatsoever. What's the reason for it? Because we have a high pressure system over the interior. High pressure is subsidence, sinking air. Okay. For the formation of clouds, what do we need to have? We need to have convection. We need to have rising air. How does air rise? Warm conditions. Okay. So that's the correct answer over there. Why are line thunderstorms generally associated with summer? Because we need rising air. Let me just write it over there. Okay. We need rising air. Okay, warm conditions for rising air. I shouldn't actually write with a blue pen. That doesn't look too bad. Now, what is the source of moisture for the formation of line thunderstorms? Once again, we discussed it. This moisture coming in on the east coast. The main reason it receives this moisture, yes, you didn't guess it correctly, but it's because of this warm ocean current coming from the equatorial regions, known as the warm Mozambican current. Okay, that's the reason we experience such lovely conditions down at the east coast. That's the reason why we can enjoy the sea on the east coast because it's nice warm water. Okay, and that's because of the warm Mozambican current. It comes from the equatorial regions. Remember, when we look at the equatorial regions, only one season. Okay, it's summer. Shortest insolation that they receive during the year. That's the reason why we experience warm conditions. You will see, you find most of your tropical forests at the equatorial regions because it's so nice and warm. Okay, now let's go to our next question. We've answered that question. The source of moisture is going to be the warm Mozambican current. Why is there usually a thicker band of clouds to the east of the front? Now, as you can see, because the air coming in from the east consists of more moisture than the air coming from the west. Less moisture. Why? Because of the cool cold Benguela and because of continental climate. It moves over land. But the matter of fact is, it will have less moisture because there's a cold Benguela current on the east coast, and cold water just consists less moist air. Okay, that's the reason why. Now, if you look at the last question, 2.3.6, explain why the weather conditions associated with line thunderstorms are more severe than isolated normal thunderstorms. Okay, the simple reason for this is because of the coming together, the convergence of two different air masses. Let me just wipe a little bit clean over here. Because if you look at the situation over here, we have a convergence of pink. I can't even see that. Okay, again pink. Apologies. We have a look. There is the cool, dry air, warm, moist air. There's convergence taking place. So when we look at this convergence, convection is taking place. This is a strong uplift that's taking place over here, Great Half. Now remember, the air is being forced to rise. Why? Because this cool, dry air is convergence, pushing against the warm, moist air, creating a much stronger updraft. So that's the reason these thunderstorms, we can almost say, is more aggressive. Okay, it's not your typical thunderstorms. If you look at it, it's more severe, right? These thunderstorms that your normal high-felt thunderstorms, because there's an uplift, the convergence that takes place, causing stronger convection currents. Okay, and that's the reason we can say these thunderstorms are more severe. And when we look at more severe, what can we do? We can look at, for instance, conditions hail might form. Now, very importantly, I want to throw in an extra question over there. Just make it up, because they might ask you this. I'm just going to write it, 2.3.7. Positive and negative impact of line thunderstorms. Okay, let's have a look at the positive and negative impacts of line thunderstorms, because they play a very important role for South Africa during summer months. Now, when we look at positive and negative outcomes, always think social, economical, environmental. Okay, very importantly, we need to look at these three areas that's been affected by line thunderstorms. Now, let's just quickly write it down. If we just quickly have a look at the positives and negatives. First of all, let's just quickly, positive, negative. Okay, first of all, it can be a massive positive, because if you look at it, if you look at most of South Africa, except for the Southwestern Cape, they experience winter rainfall. So this rainfall taking place, as you can see on our diagram, if you just go back again, you can see it's mostly over the interior of South Africa. So it means, and because if you look at the date, it's summer rainfall. So very importantly, it brings much needed rain for farming. So it's a positive for farming, because they get their summer rainfall. It means they can plant. It means they can reproduce crops Okay, economically it's viable because if now we can look at the economic impact of it. Important because it's jobs, for instance, it provides employment opportunities. It means more people can go and work on farms. Okay, economically it means we can export. Okay, we can make money. Our country earns more tax. Okay, if you look at environmentally, it means places gets rain, especially if we might experience a bit of a drought. So it's more than welcome, most welcome when we experience these line thunderstorms. Yes, so that's a plus point. Okay. Socially, obviously, if people are employed, better lives, it means people are fed. It's food security taking place. Okay. So for farming, it's a plus point. Okay. We can just write employment opportunities. Yeah. With the much needed rainfall, it creates biodiversity. So it means our fauna and flora is in good condition. It's in an exceptional condition. The animal and plant life is flourishing because they receive rainfall. Okay, but unfortunately, these line thunderstorms can also be negative. I mean, let's say, like we talked about, we mentioned in the last question, we might experience severe thunderstorm. So it might cause flooding. Am I correct? Okay. So flooding can destroy crops. Socially, it can. Loss of life. People might die. Okay. Economically, it can cause damage to infrastructure. Not only because of that, loss of life, that's people, humans. But when we look at crops devastated or livestock are being killed. I mean, if you look at infrastructure, besides for the flooding, imagine if you look at the hail, the amount of damage that the hail can cause. Not only to your crops, just imagine cars. Okay, imagine your house. So yes, you need to keep these in mind when we discuss this topic, because there's always going to be advantage of having these type of climate experiences that we experience in South Africa, for instance, the line thunderstorms. So there's always a positive that we can take out, but keep in mind there's also going to be a negative. Environmentally, it might cause erosion because of the moving water. So we need to weigh it up, okay? But what can we do? So as a community, as people, we can turn these negatives into positives by planning around the negative aspect of these line thunderstorms. Okay,